Thanks everybody for being here. Move the microphone up into David land. We are going to talk about earthquake early warning systems tonight. I am the executive director of the wireless initiative at Joint Venture Silicon Valley. And Joint Venture is an organization that engages in public-private partnerships. We lead on regional initiatives, regional challenges. And we have a co-op with the U.S. Geological Survey as well. So there's a strong relationship between our organizations. And one of the things that we had, I think it was the first meeting that I ever took at Joint Venture Silicon Valley was with Ben Brooks and Sarah Minson from U.S. Geological Survey talking about crowdsourced earthquake early warning systems. And they were asking some questions about getting into the GPS chips and the phones and the operating systems, and kind of how to basically crowdsource information on earthquakes. I'll talk a little bit more about that. So of course, as Brian mentioned, we had an anniversary recently for the 1906 quake. We had the earthquake in Nepal in April. Coincidentally, I was involved with that earthquake by virtue of the fact that I'm part of an organization that's called Radio Mala, which is an organization that's been working to bring amateur radio into the country of Nepal. About 5 years ago, Nepal had 5 licensed amateurs in the country, and today they have over 100. And it's through the efforts of Tribhuvan University. So the systems that we had in place, which included a VHF repeater, were used during the Kathmandu, the post-quake disaster recovery, and of course, the Tohoku quake, Chile, a recent earthquake in Ecuador, recent earthquakes on the southern islands of Japan, and then locally for us, we have Loma Prieta and the Hayward quake, of course. So how many people, when you say the Great San Francisco earthquake, what do you think of? You think of 1906. What you don't realize is that the Great San Francisco earthquake was actually, for many years, was the 1868 quake until 1906 occurred. But the Hayward fault is very active and is potential for delivering much larger earthquakes. That fault breaks, I want to say it's like every 140 years. And so we're overdue for the Hayward quake at this point. And if it's a full fault slip, it could potentially affect all the way from up into the Suisun Bay part, up towards Marin County, all the way down here into San Jose, and then if there are adjunct quakes like Calavera. So we should certainly be very concerned about preparing for major quakes along the Hayward fault is the primary concern at this point. So early warning systems would potentially give you time to react, and it might give you an opportunity to shut down transit, might give you an opportunity to shut down pipelines, turn off water, take shelter, get under a desk, and this is not minutes of warning, but it's potentially enough to mitigate some of the damage that would occur from these major quakes. And of course, earthquake early warning system for nuclear facilities would be very important too, and as we had saw in the Fukushima disaster, had they been able to insert the damping rods before the quake hit, that wouldn't have been. But I guess it was the tsunami that really caused that damage, and it was they built a wall and said, oh, this is going to withstand a certain tsunami, and then the tsunami wound up breaching that wall. But nevertheless, if you have a nuclear facility, you probably want to shut it down before the majority of the quake hits. So the challenges to earthquake early warning are that we have to deploy large networks over a wide area. They have to have very low latency communications. Obviously, you want to get the information into the system. You want to do your calculations very quickly. You want to get the communication outbound as fast as possible. And then you want to avoid false alarms, because if you're constantly falsing, eventually people will go, oh, it's that stupid earthquake system, and then they'll ignore it. And then when cried wolf, boy who cried wolf problems occurs. So these are certainly things that an earthquake early warning system has to, these criteria have to meet. Now, possible solutions would be lots of sensors buried in the ground, custom designs. They're highly accurate. They're purpose-built for this, so they do well for what they're designed to do. The drawbacks are that you have to find places to install them. You have to install them. You have to power them. You got to get funding to buy all the equipment and the manpower that's necessary to install them, and then they have to be maintained over time. The other option is lots of sensors, phones, right? So we're all carrying phones, and those phones could potentially be used as sensors. And so the idea is to crowdsource the information. You get not only the data in from the phone, but of course the phones are likely targets for the alerts anyway. So it's both a sensing platform and the platform on which you obtain your alerts. The drawbacks are that you have to derive data from a rather chaotic source of information, and that we're all bouncing around all the time and moving our phones and driving in cars. But if every phone in San Francisco suddenly moved a half an inch in one direction, you could mathematically subtract out all of the chaotic noise and determine that something had just occurred. Power drain on the app. I mean, everybody likes their phones to last forever, so the app has to be low drain, low load on the CPU and low load on the battery. And then you've got the issues of how do you get the vendors to agree. You need the chipset, the GPS chipset vendors to agree. You need the Android or iOS to be part of that. The phone manufacturers have to be part of this discussion. And you could make the argument that there's a public good and that you should do it. But at the end of the day, it's a $0 value proposition for them. It's an unfunded request. It's not a mandate, unfunded request. So how do you convince Apple, for example, to allow you that level of access into their GPS chips? So that's the challenge of using the phones. My understanding of having talked to Sarah Minson earlier this evening, and she gave me an update on what's going on with that project. They've begun doing a what they call a phone in a box. So I guess they're doing a phone development platform, and that's giving them the ability to use the phone platform to begin to prove out some of these concepts without having to go to the Apples and Googles of the world to try to work out a deal. She said that they were able to detect some quakes, so that's good early results from that. And that's really sort of my framing on what we're going to do. And so I think at this point right now, we're going to begin to call up the presenters. And we're just going to go through the list. And I'm going to introduce our first presenter.